In this article, we study about if the given differential equation m dx plus n dy is equal to 0 is not exact. So we can use this method. Third, in the differential equation, in the equation m dx plus n dy is equal to 0, if del n by del x minus del m by del y multiplied by 1 upon m is the function of y alone, that is fy, then integrating factor that is I dot f is equal to e to the power integration of fy dy. Here we use this method if the given differential equation m dx plus n dy is equal to 0 is not exact. So in some questions we use this method if del n by del x minus del m by del y multiplied by 1 upon m is the function of y alone, that is fy, then integrating factor is e to the power integration fy dy. If in the given differential equation we multiply this integrating factor, the given equation reduces into exact form. Now we understand some question on this method. Third, here the question is solve the equation xy³ plus y dx plus 2 times x square y square plus x plus y to the power 4 dy. First we compare this given differential equation by m dx plus n dy is equal to 0. Here we can see the coefficient of dx is m, here the coefficient of dx is xy³ plus y, so here m is xy³ plus y. Similarly, here the coefficient of dy is capital M, here the coefficient of dy is 2 times x square y square plus x plus y to the power 4, so n this is equal to 2 times x square y square plus x plus y to the power 4. So here first we check either this equation is exact or not. So for this we differentiate m partially with respect to y. When we differentiate m partially with respect to y, so this x is constant, and differentiation of y cube with respect to y, this is 3y square, and differentiation of y with respect to y, this is 1. Now we differentiate this n partially with respect to x, so here 2 is constant, and when we differentiate x square y square with respect to x partially, so y square is constant here, and differentiation of x square with respect to x, this is 2x, plus here when we differentiate x with respect to x we get 1 here, and differentiation of y to the power 4 with respect to x, this is equal to 0 because here we differentiate partially. So first we compare the given differential equation by m dx plus n dy is equal to 0. Here we can see the coefficient of dx is m, here the coefficient of dx is xy³ plus y, so m is equal to xy³ plus y. Similarly, here the coefficient of dy is n, here the coefficient of dy is 2 times x square y square plus x plus y to the power 4. Now we differentiate m partially with respect to y and we get del m by del y. Similarly, we differentiate n partially with respect to x, so we get del n by del x. Here we can see that del m by del y is not equal to del n by del x. So the given equation is not exact. Now we using some methods. Here we use method third. So first we subtract del m by del y from del n by del x and multiply by 1 upon m. So m is here, we can see here, this is x y cube plus y, this is 1, and when we differentiate del m by del x, so this is 2 to the 4 x y square plus 2 minus here this is 3x y square minus 1. Now we can see here this is 4xy square minus 3xy square, this is xy square, and here 2 minus 1, this is 1 here. Now we taking common y in these two terms, we get here xy square plus 1. So this xy square plus 1 is cancelled out, so we get here 1 upon y. Here this is the function of y alone. Here we can see that when we calculate del n by del x minus del m upon del y multiplied by 1 upon m, we get 1 upon y, and this is function of y alone. So here we take integrating factor. So integrating factor I dot f, this is the integrating factor, this is equal to e to the power integration of fy dy. Now we can write this e to the power integration of 1 upon y dy, and we know that when we integrate 1 upon y with respect to y, so we get here log y, and e to the power log y, this is equal to y. So the integrating factor is y here. Now when we multiply the given differential equation, it reduces into exact form. So we multiply the given equation by y, so we get here x y to the power 4 plus y square dx plus 2 times x square y cube plus xy plus y to the power 5 dy is equal to 0. So when we multiply the given differential equation by the integrating factor, we can see here the given equation reduces to the exact form. Here the integrating factor is y, so in the given differential equation we multiply by y, so this is x y to the power 4 plus y square dx plus 2 times x square y cube plus xy plus y to the power 5 dy is equal to 0. Now this equation is exact, so we write here solution of the given differential equation. Of this differential equation, we know that this can be written integration of m dx plus n1 dy is equal to c, and we know that n1 is obtained from n, and we take those terms of n in which x is not present. So m is here this coefficient of dx, that is x y to the power 4 plus y square dx, and n1 is obtained from n, and here in this term x is x square, in this term x, so here x is present, and in this term x is not present, so we take these terms with multiply with 2, we get n1. So here n1 is obtained from n, and in n1 we take those terms of n in which x is absent. So here x is absent in this third term, so we take n1 is equal to 2y to the power 5. Now we integrate this with respect to x, so y to the power 4 is constant, and integration of x is x square divided by 2. When we integrate y square with respect to x, so y square is constant and integration of dx is x here. And when we differentiate y to the power 5 with respect to y, So we get here y to the power 6 divided by 6. This is equal to c1. Suppose we take here constant c1. Now we multiply whole of the equation by 6. So we get here 3x square y to the power 4 plus 6xy square plus 2y to the power 6 is equal to 6c1. We know that c1 is constant, 6 is also constant, so the product of 6 and c1 is also constant. So we can take here, in place of 6 c1 we can take here c. So this can be written as 3x square y to the power 4 plus 6xy square plus 2 to the power 2 multiplied by y to the power 6 is equal to c. So this is the solution of the given differential equation. So in the given differential equation, first we compare with m dx plus n dy is equal to 0 and find capital M and capital N. After that we differentiate partially with respect to m, partially with respect to y and x to m and n. We differentiate m partially with respect to y. After that we differentiate n partially with respect to x. So we get here del m by del y and del n by del x both are not equal. So the given equation is not exact. Now we apply here third method. So we calculate here del n by del x minus del m by del y multiplied by 1 upon m. So we get here 1 upon y, which is the function of y alone. Suppose that this is equal to fy. So the integrating factor is e to the power integration of fy dy. When we integrate 1 upon y with respect to y, we get log y. So e to the power log y, this is equal to y. When we multiply the given differential equation by the integrating factor, it reduces into the exact form. So when we multiply y by the given differential equation, we get x y to the power 4 plus y square dx plus 2 times x square y cube plus xy plus y to the power 5 dy is equal to 0. Now this equation is exact. So we write here solution of this equation. So solution of this equation can be written as integration of m dx plus integration of n1 dy is equal to c1, where n1 is obtained from n and we take those term of n in which term x is absent. So in the third term 2y to the power 5, we can see here x is absent. So n1 is here 2y to the power 5. And m is the coefficient of dx here, that is xy to the power 4 plus y square. Now we integrate, we get 3x square y to the power 4 plus 6xy square plus 2y to the power 6 is equal to c. So this is the solution of the given differential equation. Thank you.